Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, let me tell you something interesting about today's lecture. Of course, we are going to get over with the most of the concepts around Gauss Law by the end of this lecture. But anyway, you will, have a lot of questions in your JEE Mains and JEE Advanced from Gauss Law. Hi Devarara, hi Varun, hi. Hi Varun, and very good evening guys. And yes, so students, today we will be understanding one of the most important thing around Gauss Law. It's one of the most asked topic, and you should know when to apply, when not to apply, and how to apply or not to apply. Up until now, whatever we have dealt with Gauss Law was, I think, easy, and this is also going to be that easy only. There is no complication in Gauss Law, and you should know when to apply Gauss Law, how to apply Gauss Law. It should be clear by the end of this lecture, and I believe it will be clear given that you focus a little bit. Okay, so it's a very simple lecture. It's going to be a short lecture, so don't worry about it. And students, that being said, students who don't know me, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And guys, if you are not yet on our Telegram channel, quickly get onto our Telegram channel by downloading this Telegram app. You can download the Telegram app from the Google Play Store and App Store. And yes, so once you download this Telegram app, you can click onto this link. This link is available in the description box on the YouTube video that you're watching. Just click on that description box and you'll be able to see this link, or else just type in JEE_English. So why should you get onto this Telegram channel? You will get before time updates on everything that is happening on JEE English channel, or anything, any lectures that we conduct on Unacademy learning, any special classes, and there are many such free of cost, special, interesting, many such important special classes going on. So do quickly get onto this Telegram channel to get before time updates, and many things like DBBs etc. are posted on Telegram channel. And that being said, students, if you haven't yet completed units, dimensions and measurement lectures yet, do complete it. One of the easiest thing for your JEE Mains and JEE Advanced preparation. And guys, let me tell you, it was all covered in 4 back-to-back session along with the 5th extra session. So it's the time to cover this A to Z of units, dimensions and measurements. And you have to only literally give a day or two, and you will be thorough with the concepts. And all you need to do is download an Unacademy learning app, of course, if you don't have one, and attend these classes on Unacademy learning app. It's all available on Unacademy learning app for free of cost. You can check it out. And yes, of course, it's the easiest topic, it's the less time consuming, and definitely asked topic in your JEE Mains and JEE Advanced. So do complete it. If you haven't yet completed, this is the time to do it. Okay, it's the low hanging fruit. Varun, post this session, you can do a thing. There is a strategy video on which we have guaranteed a very good question by Varun. The guaranteed topics would be current and electricity, units, dimensions and measurements, but it's not a very heavyweight topic. I wouldn't say this is a heavyweight topic, but as a subtopic, as a easy topic, you typically get 1 questions to 2 questions from this thing. It's a very easy one. It takes less amount of time. And current electricity is, of course, the most asked, and comes magnetism. It depends upon your preparation level, whether you want to go for magnetism or whether you want to first of all complete current electricity and then move to magnetism, etc. And magnetism, and then comes in terms of some in JEE Mains, rotational mechanics is asked a lot. And then I would say what is not most asked would be NLM, work power energy, sometimes properties of solids, etc. There are a few topics, but generally most of the topics are asked. But most of asked topics, I would say optics, etc. Okay, you can once check out the strategy video that we just made, in which we discussed low hanging fruits, etc. After this session, you can once go and have a look at that thing. Entire list has been given to you, especially if you're 2021 aspirant. That is the video to watch. Do not miss out that video. It's made for you with a lot of analysis and at the end of the session you get a strategy to solve, you know, your whether you should be going for PYQs or whether you should not be going for PYQs, how to complete the syllabus in the given time, and to achieve that success that you can. Current and electricity, I would say magnetism, next comes optics, next comes, you know, like nuclear physics, and then comes thermodynamics, and then comes of course one of them is like units, dimensions, measurements, definitely asked. You may want to check out the frequently asked session. So yes guys, these lectures are available for free of cost on Unacademy learning app, and you may want to type in Unacademy in your Google Play Store and App Store, and definitely want to type it in and then search us. It's going to be the first search result, the most downloaded learning app with many such free of cost features. Once you click onto that and click on that install button, there you go, you will get live updates for the educators that you follow, and also on very important lectures for your JEE Mains and JEE Advanced preparation. And guys, not only that, we also give you access to quiz feature, which is free of cost, which comes with all the kind of PYQs and model problems that you can expect in JEE Mains and JEE Advanced. You're welcome, Varun. So yes guys, that being said, if you're looking for a complete package, a champion's tool, and the best thing that you can have for your JEE Mains and JEE Advanced preparation, that is going to be an Unacademy subscription. And guys, you know what, it is the best thing. It is not only the best thing that you can have for your JEE Mains and JEE Advanced preparation, but it is the complete thing that you can have for your JEE Mains and JEE Advanced preparation. It comes with everything that you need for your JEE Mains and JEE Advanced preparation. What do I mean by everything? The best educators across the nation, the national level test series, and more importantly, the environment like what you want for your JEE Mains and JEE Advanced preparation. Yes, the best educators are all available on one single place, that is going to be Unacademy subscription. And guys, you can get your doubts cleared from them, and you will go in a very scheduled and a structured manner. And guys, this is very important for your success in your JEE Mains and JEE Advanced, especially to become a champion. This is the thing that you need. And you can, you know, what is going to be a structured program? Structured program is going to be one where you are going to undergo an intensive and extensive program where you will be attending daily interactive classes with the best educators. And not only that, you after attending, you know, this classes, you will also have dedicated doubt clearing session and mega quizzes, national level test series, and leaderboards and dashboard, and you will experience the environment that you want for your JEE Mains and JEE Advanced, a competitive environment. Of course, it's a competition, and to a great extent. So yes, you want to have a platform like this. And guys, how do you get this? All you need to do is click on the left hand top corner extension bar, and then you will choose IIT plus, and then you will choose IIT JEE as your goal. With this, you will be preparing for both JEE Mains and JEE Advanced, and then you will click on the get subscription. And guys, what is the speciality? You know, it's one subscription, unlimited access. So why wait? It's the time, guys. And Varun, I don't know when will the JEE Mains exam be conducted. A really good question from Varun. When the JEE Mains exam will be conducted? Like, you know, one of the students today in the lecture came up with a very different perspective, where I believe you should be preparing, you know, targeting that the exam will be conducted anywhere around 1st or 2nd week of February. Keep your deadline max to max 15 Jan or until end of the Jan, but move very smartly. Varun, from your question, I'm assuming you're a 2021 aspirant, hence you're worried about when the JEE Mains and JEE Advanced will be conducted. So if that is the case, you should be what you should be doing is like you should be focusing on your strategy. I can't you know, recommend like, you know, anything randomly for you. But you may want to once go through the strategy video and decide what is the thing that you want to do. I am probably assuming by the 1st week of Feb you will have your exam. So yes guys, that being said, this entire thing, this special package, this champions tool, and the best thing that you can have for your JEE Mains comes at an affordable price of only 2,100 per month. And this is less than 70 rupees a day. And everything you get for 70 rupees a day, less than 70 rupees a day, guys. And you can apply Murlidharan coupon to get to this best price point and to get the best discount on your subscription purchase. And students, that being said, hi Divya, good evening, and you are here on the correct time. And that being said, students, yeah, like you know what, you can again do a very awesome thing on Unacademy. That is, you can make use of our pay in parts feature to split your payments into multiple parts, and you don't have to go through the hassle of paying all the fee at once. You can typically also make use of no cost EMI option, which is also available on our Unacademy, which will also reduce the burden of paying all the fee at once. Yes, these are like two typical options you want to check out while purchasing an Unacademy subscription. And we also have traditional payment modes like debit card, credit card, UPI, etc. And guys, that being said, you know what, your 12-month subscription is also pretty economical, and this is typically meant for long-term dropper 12th class students. Yes, it's meant for dropper 12th class and long-term students. And guys, this is the time to get started, and these all again comes at a price of less than 2,900 per month. Yes, it's only 2,888 only. And guys, you know what, this everything, what it is all coming along with 6,000, 7,000 plus recorded you know, material and kind of video books from the best educators across the nation, with 1,000 plus daily live interactive classes going on. So this is the time to get started. Don't miss it out, and do not forget to apply Murlidharan coupon to miss any discount on your subscription purchase. So you'll get the best discount by applying Murlidharan coupon. But that being said, this is the time, guys, and also the optics has began, and we are to enter refraction. Don't miss out the classes. Enroll soon if you're on an Unacademy subscription, and if you're not yet on an Unacademy subscription planning to purchase it, this is the time to get started. And we have discussed so many interesting topics, and we have so many amazing students. And the other added advantage of an Unacademy subscription is you have really students coming up with, you know, different perspectives on this daily interactive classes. And guys, this is an optics basics to advanced course where you will get complete information on optics from basics until advanced in, you know, like 60 sessions with, you know, like 60 and, you know, like 100 and odd different concepts, and like, you know, anywhere around 300 to 400 model problems. So do not miss out this session if you're already on an Unacademy subscription. And if you're not yet on an Unacademy subscription planning to purchase it, this is the time to get started, because most of the educators are hosting an Unacademy you know, like programs dedicated for your JEE Mains preparation, JEE Mains and JEE Advanced preparation. And that being said, our team is also available on an Unacademy subscription platform. And guys, we have started courses on electromagnetism, differential calculus, and as well as some kinematics and optics basics to advance. And for 2022 aspirants, we have courses on mechanics, redox and equivalent reactions, and graph sets and relation. And do remember, practice, practice, and practice makes human perfect, but Gauss law is something where concept alone can make you perfect. And let's get into this interesting lecture then. And guys, this is a very easy question. Once you may want to have a look at the question and, you know, have a look at it for a couple of minutes and quickly come to the answer. Okay. And anyway, this looks like a ring, but this is not a ring. And, you know, like this is a 3D kind of sphere. And this is not a sphere, it's actually a shell. You can assume this, you know, distance to be very small, or this, you know, thickness to be very small. And you can say this del is very small. Okay, and what is being asked? The electric field at a distance A. And guys, today's lecture is one of those lectures, I mean, those topics can also be asked, and they have been also been asked. But this is one of the frequently asked concepts in Gauss law. And Gauss law is one of the frequently asked concepts in, you know, your electrostatics. It is less time consuming, it's an easy one. But you need to really know how to apply it, when to apply it, and how not to apply it, when not to apply it. And how does it all work? And there are a few concepts. Today we are going to deal with the most critical part of Gauss law and get started on the question. So electric field at a distance A from the center of an ideal copper shell of radius r with surface charge density sigma, where r is greater than A, where the radius of the shell is greater than that of the distance at which you are assessing the electric field. Alright, this is quite an easy question for many of you. Good, Prabhat. Very good. The answer is 0s. Why? Charge enclosed is 0. What is the charge enclosed? All the charge lies on the surface of the shell. So, in this case, what would the charge enclosed be? 0. and if charge enclosed is 0 divided by epsilon naught is also 0, that means electric field into area is 0, and you know area is not 0, hence electric field should be 0. Simple. Why it is 0? Ever you come across such cases, charge enclosed, if it is 0, then simply from Gauss law you can say that electric field is 0 at that point. Very simple. And what is the direction of electric field, guys? What is the direction of electric field? Direction of electric field is going to be generally radial if it exists at all. But let's come to a very interesting thing. Up until where the charge enclosed is going to be 0. Okay. The charge enclosed is going to be 0 until it approaches A, approaches R. Until then, charge enclosed is going to be 0, which also means electric field is going to be 0. Right? Some or very important thing. Okay. So one of the popular kind of questions can be a graphing thing, and this is a key thing. It can be, even a cube, it can be, very random structure. Okay, we'll come to each and every point, but it can be also random structure. Whenever you see charge enclosed is 0, electric field is 0. Good, it's going to be radial. Yeah, correct. Now, how about this, Prabhat? How about the students get started on this? Electric field at a distance A from the center of an ideal copper shell of radius r with charge density sigma. What is this? This is charge per unit area. You can say this is Q by A. But that is not being asked. Notice always the question. Don't ever jump to a conclusion or to a solution without having a look at the option. Everything is given in terms of sigma. Whether do you think in this case it's going to be 0, or if it's for a point which is which is lying at a distance greater than that of radius, or at a distance farther from the radius. There is a very, very interesting thing that you'll notice, and I believe we discussed this at the beginning during Coulomb's law, and we'll come to this conclusion by the end of this program. But get started on it, have a look at it. It's quite an easy problem. All you need to do is apply Gauss Law. What kind of Gaussian surface will you take for this kind of thing? The similar one to the earlier one. Earlier one we didn't worry about much. We said anyway there is no charge enclosed. Whatever kind of Gaussian surface you take, it will be 0. But since the radial electric field would exist, you take a spherical Gaussian surface, right? You take a spherical Gaussian surface. So yes, we would have a spherical Gaussian surface at a distance A from the center of the sphere. Okay, this is a Gaussian surface, and it should be good. Very good. Did you make any conclusion? Did you try to substitute the value of do a thing, Prabhat? One interesting thing that you can come is try to substitute the value of sigma is equal to Q by A. So whatever area you have taken, and you will come up with a very interesting insight. Yes, what is the area of this Gaussian surface? 4 pi A square. D is correct or A is correct? No. Okay, there is a small mistake, guys. It should be all A. Okay, I don't know which. It's a good question. There is an issue in the option. So let me correct this. So instead of in this every case, put R is equal to A. Okay, so option 1 would be something like sigma R square divided by epsilon naught A square. Okay, and this is sigma by epsilon naught, and this is going to be sigma A square divided by epsilon naught R square. So some of you, if you understood the initial concepts really well, if not, this is the time you are getting started, don't worry about it. This has been told just in terms of words. I've just conveyed in terms of words to you, but post this question, you will notice that phenomena that we have discussed. No, Prabhat, your first answer was correct. Redo it. Your first answer was correct, right? So let's do a thing. Let me write down the area of this Gaussian surface. As you understood, first of all, let me tell you something. A spherical surface would have always okay, I'll come to that point. It would actually have as if the charge is concentrated at this end. It would appear as if the sigma into A charge is concentrated at this end. But that being said, how would the fields be? Fields would be always be radial. Electric fields are always going to be radial. If you think about a point charge, what would it do? It would generate fields radial in all directions. So we would not deal with the concept of writing down x cap, y cap. We would rather deal with the concept of writing down r. So what is the area in this case of this Gaussian surface? 4 pi a square. Since this is at a distance a from your center of the sphere. But that is not how we are concerned about. We are only concerned about electric field direction to finally come up with E dot A. Okay, there is no other reason that we did it. So if this is area, then what is the other thing that we need to know? We need to know what is the charge enclosed. Charge enclosed in this case is going to be sigma into area of this shell. Charge enclosed in this case is going to be how much? Charge enclosed is going to be, moment guys, sigma into area of the sphere. And what is sigma into area of the sphere? Sigma into area of the sphere is what? It is nothing but sigma surface charge density, sigma area of the sphere. What is the area of the sphere? Radius is given to us as r, sigma into 4 pi r. Quite simple. All right, there you go. You got the answer. That's it. Here we are considering all the charges, that is Gaussian surface outside the charge. Yes. So what is the, then Prabhat, in that case, what is the charge enclosed? What should be the charge enclosed? Everything, right? Sigma into A. How much charge you are enclosing? You are of course considering the sphere inside, right? You are considering a Gaussian surface, right? You're correct. That is correct. And just keep moving for now, and let's do a thing. Okay, this is charge enclosed. We found out charge enclosed. Now we will write down the Gaussian equation. The Gaussian equation. And what is the area vector? Area vector is something like, I'm talking about this Gaussian surface which has 4 pi a square area, is nothing but 4 pi a square into r cap. We know electric field is going to be in the r cap direction. Depending upon whether it's positive, negative, it's going to be minus r cap or plus r cap. Now let's just assume it's just depending upon the charge, even the sigma sign will change, everything will change. So we need not probably worry about it unless explicitly being asked. So we will say electric field is also something like I'll say something like ER cap. Just give it a magnitude E. It's in the direction R cap. It is just magnitude. Very good. Very good, Prabhat. So that means what do you need to do anymore? You don't need to put in much effort. Simply do an E dot A and then you'll get flux, right? If I do E dot A, I'll get flux. Why are we doing this? We are going to get into Gauss Law, of course. The easiest method to solve problem. You do E dot A, r cap, dot r cap, it's 1. So you would have E into 4 pi A square. Really simple. Now this is electric flux. Now you have some value of electric flux. Now what do you need to do? You need to equate it in terms of Gauss law. Gauss law says that charge enclosed divided by permittivity epsilon naught, this case, is equal to flux, electric flux, which we obtain to be like E into 4 pi A square, right? And no syllabus has been until now officially announced. If any news came up today, I don't know, but until now no syllabus has been officially announced, deleted for your JEE Mains. Up until now it did not come to my notice. Have you noticed anything? Please. So yes, what was this thing that we derived earlier? Sigma into 4 pi r square. Divided by epsilon naught is equal to E into 4 pi A square. If you come across something like saying that syllabus has been deleted, R is equal to A, field will be sigma. Yeah, that's correct, Prabha. We'll come to that point. That's correct. Well noticed. Good. So, like what Prabhat is also saying, if I'm going to put an E bar and we know it should be in the R cap direction, I can say something like this. Let me do a thing. Let me write it down something like this. What I'm going to do, I'm going to write down something in the bracket. Sigma into radius of this shell, into radius of the shell whole square divided by epsilon naught into 1 by A square. So what is happening in this case? This thing is constant. Exactly. When it is going to be maximum, when A is equal to R, right? This E is maximum. I'm just talking about magnitude. E is maximum when A is equal to R. If A is equal to R, E is maximum. Substitute it, you'll get the E max value to be something like we had like sigma R square divided by epsilon naught divided by A square. So it would be sigma by just epsilon naught. Isn't it? Yeah. Right? Yeah. So that is it. This is maximum, but the equation is not this. The equation is something like this. The equation says that when E is equal to 0, when just we are coming to not just dealing with this challenge problem, but to the entire solution. We are integrated to the entire solution. Option D is wrong, right? Option D is wrong. Prabhat, notice it carefully. A is over here, A square is over here. Okay, I'll tell you one of the things maybe that you want to understand at the end of this lecture. Okay, E is 0 when this A is greater than R. If I say this is R, A is greater than R, or sorry, A is less than R, or R is greater than A. When A is less than R, we have E is equal to 0. When E is how much? Epsilon sigma into R square divided by epsilon naught into 1 by A square when A is greater than R. Right, really simple. Now let me do a thing. If this is a confusion that times students, that's why I got an option like this for you guys. so that you understand that point specifically, and you can write it down into R cap, etc. So the thing that you need to understand is we are coming to one of the postulates or one of the exceptions of Gauss law, of Coulomb's law. Okay, in Coulomb's law, we said that if you have a spherical shell or conducting spherical sphere and you give a charge on the top of it or on the surface, one, it would be uniformly distributed and it would act as if there is a charge at the center of the shell. Now do a thing, substitute sigma is equal to q by 4 pi r square. What are we getting? You will get something like this: q by 4 pi epsilon naught into 1 by a square, or you can write it down as 1 by r square. What does this state? This states as if this guy over here is producing the field as if the charge is present at, all the charges are present at center of the sphere. You will notice this thing a lot. And we know E from here that E is proportional to 1 by r square. This is a thing. So these two things do match. It is actually as if the charge is present at the center. This was one of the postulates of Coulomb's law, saying that okay, if you have a spherical shell or a sphere with charge on it, then you know what, it will act as if all the charges are present at center. That's what we found out too, right, using Gauss law. So a very important thing, even though it's a very easy thing, it is necessary to discuss. Okay, so we have what are we going to do? Most of you did understand this. This is a thing that typically comes up in your exam, and especially in JEE Advanced, you can notice so many questions around. So I'm going to say two things. This is the electric field magnitude, and this is the distance A, or let's keep it as R, because you generally used R. Okay, now what I'm saying is the electric field. Okay, electric field is maximum, and then this got out of the way. So let me put it here. Okay, this is supposed to be electric field, and I hope you know this graph. What's your question? Yeah, graph, very important. Okay, I hope you got it, Prabhat. That's not the way to remember it, Prabhat, but that's a postulate, you know, that's like a postulate. What is the maximum value? Sigma by epsilon naught. And over here, what is the maximum? When does the maximum electric field appear? When A is equal to radius distance R. So on this surface, you're measuring just a delta distance away from the surface, or just on the surface, the electric field is maximum. And as you keep moving away from the surface, it reduces by 1 by R. Okay. Should be y is equal to 1 by r square. Okay, some k into 1 by r square. 1 by x square graph, and this y. Okay, so this tells you electric field. Let me do it the other way around. Okay. This is very important, but most asked, you know, this would be a little bit more steeper. This would not be, you know, like this, little bit more steeper it should be. But anyway, this tells you that electric field is proportional to 1 by r. And electric field is maximum over here. And what is happening between this distance? It's all zero. It was all zero. Okay, just a field line should begin at A is equal to R, or R is equal to R, and it will go until infinite and will eventually become zero again. Okay, it will begin over here at this point and it will come down. Alright, let's get into the next problem then. So an electric field at a distance a from the center of a plastic shell of radius r with uniform charge density sigma, where r is greater than sigma, then what happens? Do you think something will change in this case? So let me put this question this way. So if you're giving a charge sigma on a plastic shell, which is an insulator, okay, it wouldn't behave like a spherical shell. In spherical shell, what would happen if we add a spherical shell? Let's quickly get into this point. So let's say this was not like plastic, rather spherical shell. Okay, sorry, conducting shell. What I meant was like conducting shell. If it was all conducting shell, all the charges would accumulate on the surface. Hence, you would have no field inside. We have here some charges that will all accumulate on the top, on its surface, on the top of the surface. So there would be no field. So what if it was, insulator, and you have given it some charge? Maybe there would be charge distribution everywhere. And now you're trying to assess the, electric field at a point A, where this A is less than the radius of the shell. Good, very good. Nothing changes. Nothing changes. Very good, Prabhat. Very good. So what happens? It's going to be only 0, guys. Right? Because if I draw a Gaussian surface, which is going to be spherical Gaussian surface, charge enclosed is 0. If charge enclosed is 0, then from Gauss law we can say flux is 0, and charge enclosed is 0. Epsilon naught. It's flux. 0 by something, it's 0. And we know area is not 0. Electric field was supposed to be radial if this A's distance was large enough. So guys, electric field should be 0 since area is not equal to 0. Right? Very amazing. How about in this case, something going to change? The electric field at a distance a from the center of the plastic of shell of radius a with uniform charge density sigma, okay, where r is less than a, which means the point A lies outside the sphere, outside the plastic shell. What do you think is going to happen in this case? Okay, does anything change now? That's the question. And one more small change to this option. It should be all, it's not r, just change r is equal to a. Put r is equal to a. Okay. Instead of I wrote it down as r over here, just change it to quickly to a. Would anything change, students, in this case? Do you think is something going to change? Yes or no? Okay, let's quickly do the math. So there's nothing, guys, it's just the math. I don't think anything will change. Yes, nothing will change. Very good, Prabha. Nothing will change, guys. What is going to be changing? Nothing, right? The charge enclosed is going to be the same. I mean, in terms of not absolute, the charge density can be different in insulators, the charge density can be different in conductors. But what I'm saying is, if you have uniform charge density sigma on this shell, be it spherical or insulator, the field is going to be the same, right? And you got to a, yeah, good, very good, Prabha. Yeah. So again, the same thing you'll have to do. You'll say area of this Gaussian surface is how much? 4 pi a square in this case, and you'll say the charge enclosed is how much? Q into epsilon naught, and sigma into a. Sigma into a. There is no difference in the kind of thing that we need to do, but you can anyway do the math. But I'll quickly just do the math for you. But this should be a second practice around this anyway. So this would be 4 pi capital R square, where this is the distance r. This is the shell radius. Okay, typically this much charge is available. If some okay, one more important thing, students. Okay, this is something that I wanted to bring it to your notice. So let's say charge density is given, a surface charge density rather, let's say something like volumetric charge density or space charge density is given, and let's say it's given as there is some shell thickness given to you in case of insulators or plastic. What would you do? You multiply this with delta R. Okay, you will multiply this entire value. So what do I mean to say is, instead of this question is typically the same question, hence we need to only do the math, hence I'm just jumping into a very interesting concept. So let's say instead of sigma, I've given it not just on the surface but throughout the volume. Okay, so if I've given it throughout the volume, even in the delta R some charges do exist. So in that case, you would say not charge enclosed is sigma into A, but rho into A into delta R, which is nothing but volume. Okay, then in that case, typically it would be told to you that it's not areal charge density, but rather spatial charge density or volume charge density. But generally, when we are dealing with shells, we deal with area charge density or like your surface charge density. Can be volumetric charge density. But now here comes the case of what? Insulators. But what do you think would happen in the case of conductors? Nothing. It will remain on the surface only. It will remain on the surface. So you can't typically use a rho. Generally, you do use a rho, you need a conversion factor. You typically write it down as sigma into area, because all the charges would come and accumulate on the surface. Even let's say bunch of charge has been given to it, like even rho into A into delta R charge somehow has been given on that sphere, which is not possible. It will all come onto the surface. Okay, this is for conductor, but for insulator, if something like this is given, you need to make use of. Okay, we'll come to that point later on. For now, just let's get into this problem. This problem is nothing. This is the same thing. Graph would look similar, so we will not be drawing graph. So what we would be doing is typically 2 lines to just show you how the problem can be done very quickly and how easy is this concept. Given any such thing, it's a very easy one, guys. Alright. Oh yes. So you do sigma into A, and this is charge enclosed. We have area. What are we going to do? We need to do some math. I'm even skipping this page. I don't think this is even necessary. So since it's a very simple problem, I'm just directly going to derive the final equation, saying the charge enclosed by sigma epsilon. In fact, I'm writing down quite a few number of steps, which is not even necessary once you have started doing this. Okay. This is going to be E into A. We understood both are in the radial direction. It should be 4 pi A square. This area. It's sort of we are doing this exercise again, but anyway, it's a very simple question. So Q we know is what? It's sigma into A. Sigma into A, which radius? We are only going to consider this radius. But if delta R was given and rho was given, you will consider rho into 4 pi R square into delta R. Alright. That is all you need to do. So charge enclosed in this case is how much? It's going to be sigma into 4 pi R square divided by epsilon naught. There you go. You got the electric field. The graph is also not going to change. It will look the same up until, as you have seen, up until the rim, there wouldn't be any electric field. But beyond that rim, it would act like a point charge. The things haven't changed. That is what I'm saying. It hasn't changed yet, is it? But it may change eventually. You never know. Okay, let's get into this point, guys. There we go. Just wrap this up in a nice, like purple color, but anyway. Okay, that is it. It's the same thing. Like it is as if the charge is concentrated at the center. Things haven't changed yet and things are fine up until now. Let's take up a different kind of problem. Okay, a very interesting problem. Focus on this problem very carefully. Okay, focus on this problem very carefully. The electric field at a distance A from the center of plastic sphere of radius r with uniform spatial charge density or space charge density rho and dielectric constant z is given to you, where radius r is greater than that of the distance A. Quickly, students, have a look at it. Do you think whether it will be 0, whether it will be rho into A divided by z epsilon naught, or whether it would be rho into A divided by 2a z epsilon naught? Let's even remove the z over here, okay, for convenience. I'm just removing the z. Okay, but we have z in rest of them both. And whether it would be rho into A divided by 3z epsilon naught. What do you think? Remove this row z over here in the option C. Start working on the problem, guys. Start working on the problem. It's a very simple one. Alright then, I think, I believe you must have tried it out. Let's get into this problem. So now, what kind of sphere is this? This is a plastic sphere. Plastic sphere, insulator. Insulator has a dielectric constant and also a charge density, which is going to be accumulating all along, all in its volume. Okay. So from this distance to this distance, there will be charge distributed on it, inside it. Now the question is, what would be the electric field at a point A from the center? Now, what would you do? You simply draw a Gaussian surface. What kind of Gaussian surface? It should be again a spherical Gaussian surface. Things don't change over there. And what would be the area of this Gaussian surface? 4 pi a square. Sorry, this is capital, not capital R, but small a. Orange color sphere would have radius of 4 pi a square. Now the thing is, there is one thing that maybe we are probably missing out every time we are discussing about such concepts. Is going to be dielectric constant. This we will get into it. Okay. Now, what is the charge enclosed within this A? Let's get started. Methodologically, it's very easy. There is no difference. The same thing again. I'm just talking about what would be the charge enclosed within this Gaussian surface. Now, this time it's not anymore. It's not anymore a surface charge density case. So what you do, you would simply multiply this charge density rho with the volume enclosed within that, given that it's a uniform charge density. It's going to be rho into 4 by 3 pi r or pi a cube in this case. Alright, that was pretty simple, and I think just a moment. So, alright. Guys, just give me a couple of seconds. Alright. So that being said, this is a very simple case of everything. This is just cube. Why 4 by 3 pi a cube, guys? Because it is nothing but the volume. Right? This is something that you know, spherical volume. So yes, that is it. That is all it is about. So this is the charge enclosed. So it was very simple. Now we know this thing. Now I have a question. Okay, let's do a thing. Electric field, a radial again. In this case, these things are not going to change. It's going to be radial. And what is this? This is charge enclosed, and what is the area of the surface? We have that. We need to get into Gauss Law, and we need to get into the most important concept. The important thing that I wanted to discuss here, often I see this, is now what is flux? Flux is charge enclosed by epsilon, which in this case is going to be charge enclosed divided by k into epsilon naught. Okay, you would have to, sorry, in this case it's z into epsilon naught. This guy over here, I mean this plastic, this entire plastic over here has certain dielectric constant. If you multiply this, you know this from earlier things, you know, we used to use K during our capacitor chapters and but relative permittivity is the same thing as dielectric constant for the thing. Oh yes, why does this happen? Because we are not a medium where charge polarization does not happen. Charge polarization. This is how you should apply in this case the Gauss law. Just think about it. Take a point charge and analyze it, keeping in a medium, plastic medium. What do you think would happen? Some charge polarization is going to happen. Hence, if you are going to apply Gauss law, and if you are trying to get into, you know, the electric field form of the Coulomb's law, not exactly Coulomb's law, but applying it on a test charge, etc., things will not come out right. Why? Because you have probably ignored something. Right? The other way to do it is you can take electric field flux to be multiplied with Z, that is 2. I don't think yeah, multiply sigma, but this is a standard form. Okay, simple, very simple. Rest is just, you know, quite easy. So just I'm not having this semicolon over here. Just take out the semicolon. I'll be writing down everything as Q enclosed. Q enclosed was what? The rho into, we had a charge density rho into 4 by 3 pi r cube. Pi or a cube, sorry, a cube in this case, not the entire charge, right? If it's the entire charge, we will see what would be the scenario be. But anyway, let's not jump into it right now. So this would be 4 by 3 pi a cube into 1 by z epsilon naught. And we know the Gaussian area was 4 pi a square. We should be now getting into the Gauss. Okay, there's no other option then working around this equation. So I'll just keep this equation like this for now. We're going to write down the Gauss law equation, and I'll write down the corresponding parts here and there. Gauss law says flux is equal to nothing but Q enclosed by epsilon, which is in this case rho into 4 by 3 pi a cube, since a radius is only available within that spherical shell, this orange color shell, spherical, I wouldn't say spherical shell, but rather spherical Gaussian surface. In this case, you would write it down this way, and this is charge enclosed. You have got that point, and then you would write it down Z to epsilon. Now, what about flux? It's E dot A. The same thing would happen again. E dot A. What is area? Okay, everything is r cap. So I'm not writing it down. Just it is r cap. Try to understand it. Your Gaussian surface area was 4 pi a square. simply cancel out this, and you'd have the power over here would get cancelled out, rest would remain as it is. So yes, can do that thing. Okay, and cancel out 4 pi. Just don't start working around those simpler things. So it should be something like electric field should have been. Notice a very interesting thing, sigma divided by, okay, assuming it as uniform charge density. This is true, isn't it? What is that interesting thing, students? Be good. Yes, P Prabha. So what is that interesting thing? Pi is also cancelled out, right? So what is that interesting thing that you're noticing over here? Rho divided by 3z epsilon naught and into A. What does this tell you? Some constant into distance A inside the plastic sphere, some different kind of equation. Just let's keep it like this for now. Something like for now, just understand this is nothing but some constant into distance A, or generally if you used RR. But this constant has some Z factor in it. Very important, very important, very important. Even though it's a simple thing, don't miss out this concept. Often see this concept being missed out in many of the official books. So alright, the electric field, now let's get into the next problem and let's see, do we get something different. So now I'm trying to analyze the electric field at a distance A, okay, at a distance A from the center of a plastic sphere of radius r with uniform charge density rho and dielectric constant z, where r is less than A, or let's say A is at a distance away from r. Now the question is, what would be the electric field? Just write out yourself. It's a very simple one. It's again, like a 2 minutes problem. That is how much time it would take. That is the beauty of Gauss law. If you are doing it, and even using Coulomb's postulates, this is the same thing. But about inside the plastic sphere, maybe still it works. Yeah, of course that too works. Right? So yeah, substitute for Q is equal to rho into 4 pi r square. But the concept of being charge enclosed is very important. That is what Gauss law brought to the table, in terms of understanding phenomena around electric field, which is quite useful. But there are few limitations. There are few cases where you can't apply. Okay, all right. I believe you have take maybe like another 20-30 seconds or maybe like 2 minutes to solve this problem. I'll parallelly get started on this. See, now if you have already understood one of the concepts that we discussed earlier, you can simply come to the answer even without thinking much around this problem. What is going by the Gaussian method? If I'm going to say this would act like a point charge, since it's a spherical, like a surface or spherical shell or spherical sphere, a solid sphere with all the charge distribution all along its volume, but still the charge will act as if it's all concentrated at the center. In that case, if there is a point charge that is concentrated at the center, you can simply say it's nothing but k into q by r square at this distance a, in this case a square, okay, k into q by a square. Okay, substitute the value of q, this is going to be rho into 4 pi r square. You get the answer in the quickest way possible. It's like a 2 minutes problem, but let's go by Gauss law and see if something is different or whether we are getting this from Gauss law. It can be also solved from the postulates that we discussed earlier. So in this case, what is the Gaussian surface area? It's going to be 4 pi a square. This is a sphere with surface area 4 pi a square. That hasn't changed. And now the most interesting thing that you may want to know is whether the this dielectric constant will play a role or not. What do you think? Just keep thinking. Maybe you want to start commenting on this part, and maybe it's it's a very interesting thing to think about. So what is the charge enclosed within the sphere, within this Gaussian surface, within this orange color Gaussian surface? The charge enclosed is how much? Rho into the entire volume of the plastic sphere, which is going to be rho into 4 by 3 pi r cube, capital R cube. We have this thing. This is quite simple now. Now you understood everything. There is nothing in this. Now if this question comes to your mind, if at all this question comes to you, and we can move to the next thing, I believe. So if this question comes to your mind, what should be the flux be? What should the flux be? In which medium you are assessing things? It should be just epsilon naught. Assessing at a point which is in the epsilon naught. This is in the air. Why are you worried about it? It's a very simple equation. Now just keep noticing it. We have rho into 4 by 3 pi r cube into epsilon naught. I'll just keep it like this. This is sometimes quite easy to solve it this way. I'll tell you why. But your surface area has increased. Some changes you'll notice. It is actually as if the charge. You just keep Q enclosed. It's as if the charge is concentrated all at its center. Nothing has changed, right? To 1 by epsilon naught. Okay, that thing hasn't changed. Don't worry about it. So the other way to denote your flux, and I think we'll probably get into this equation, start solving. Q enclosed is equal to E dot A is equal to your Q enclosed by, from Gauss law we can say this as epsilon naught, and this is going to be what? This is a simple equation where you just multiply rho with 4 by 3 pi r cube, capital R cube, into what? Let this 3 look better. This look not like a 3, but yes, now this is a simple equation. The same thing as if the charge is concentrated all at its center. Nothing else. Here it would be a square if you know, but we are going to notice something very interesting. Okay, that is like this entire thing, this electric field now is not dependent upon the dielectric constant or the relative permittivity. 4 by 4 pi, generally this equation is kept like this so that we can see something useful for our conclusion. But yes, all right, let me do a thing. Let me write it down in, like, in that constant color that we did like earlier. But would rather be into it quickly. This rho into r cube, okay, divided by 3, and here we would have epsilon naught, and what would you have over here? 1 by a square. And in which direction? R cap direction. Yes, this you could have said in the initial phases itself when we started with the problem. You know what? Why are you doing this entire thing? I understood it's just a point charged, all focused at the center. As if all the point charge, that is rho into volume V, focused at the center. Alright, it's quite easy, guys. That is it. And of course, we need to get into the graphing part. Now, in the graphing part, you're going to observe something very interesting. And after this graphing part, I'll come to a very interesting. Okay. Now, in this case, what did you find out? You found out that the electric field is inversely proportional to 1 by a square, since this is the constant. Okay, let me do a small thing. Let me do a small, modification to what we wrote down. Could have been written this way so that understood. This is hi Ryan, hi. So pretty easy, but you know what? All the time you may not get uniform charge density, and you may not get necessarily plastic shell, and you may not directly get this question. So we'll first of all graph it out, and before graphing out we'll have some conditions, of course. And the graph would look something like this. As compared to shell, for an insulator there wasn't anything present until a distance r. But again the question comes, where would the maximum electric field lie? What is the value of maximum electric field? So if you have noticed, in this case the maximum electric field, okay, we had two equations. We'll get to the two equations. Okay, this is solved. So the option should be, we'll get to the first answer. So if you are waiting for the answer, there should not be a Z on the bottom. Hence, this is cancelled. This is cancelled. Of course, it's not. Anyway, somewhere it was not 0. Hence, the answer should have been D. But let's get into the next point. Okay, very important point that we have to discuss. So we had two equations. One said when this distance A, okay, now assume this distance A is varying and this distance A is less than R. We had an equation something like this, which said this is rho. Let me do a thing. Just make use of maybe like a different color, and it says that electric field is equal to varying with distance, which was varying something like this 3z. Okay. Z epsilon naught, that's it, into A. Yeah, go by 3z epsilon naught into A, where this A is varying. Now the other equation we had was when A is greater than R. So we had the other equation where A is greater than R, and in that case what did we have as the electric field? We add the electric field as rho into R cube divided by 3z, no z, I'm sorry, that is again a mistake. So it would just be 3 epsilon naught divided by A square. In this case it is proportional to A, in this case it is inversely proportional to A square. But from this both equation you can conclude, when this both equation are equal, then only you would see the maximum electric field. And at which point do you have max electric field? You would have max, so just you would have max electric field at A is equal to R on the surface again. And what is the value of max electric field? Quite simple, just substitute A is equal to R, and I look at the first equation. I say this is the simplest one to substitute, but what it should be? Now comes the question. The dielectric constant, or in a permittivity space, it is reducing, is probably a little outside the sphere. Okay, sorry, you should not be equating both the spheres, both the equations, but probably substituting until R. This spans until R, and this spans anywhere greater than R. A small mistake, but yeah. That being said, guys, don't equate it like in the traditional cases you would do for two equations, because ultimately we know near about the surface we would have something like this. Z is always going to reduce the value a little bit. You bring it little just away from that sphere, what would you have? Electric maximum field would suddenly jump. That is going to be rho into A divided by 3 epsilon. Good. No, graph won't be the same, guys. Let me re-graph it. I wanted to graph it a little, no, there would be a bit jump, right? What would be the jump? So this is Fourier. The graph would not look like what you're expecting. If dielectric constant is not given to you, the graph would look like what you're expecting. but no, not typically like the last one. So you have 2 points. 1 point, of course, at R within the sphere, it's going to be maximum. Okay, and just as you step out of that surface, the max field can be observed. Okay, there would be, come to this point, this is how it should look like actually. Let's say one value is something like substitute A is equal to R in this case. So one value would be that, and the other value would be, so this is electric field. Of course, you understood that point. I'll write it down again. This would be rho A divided by 3 epsilon naught, whereas the other one is rho A divided by 3 Z epsilon naught. Right? Really simple. So this is where I don't know whether if this concept is not included, just do include it. If it is included in your already in your previous, all the sessions that you have done. Sorry, this should also be changed. But and this should be not A but R, I guess. So this should be, then because the radius is R. Small changes, I'll just quickly make it. Then I'll again come to this point. So this should be rho R by 3 epsilon. Let me take red colors. I think is better. This should be rho R by 3 epsilon naught. And this should be rho R divided by 3 Z epsilon naught. Now, this until you are moving from, you're moving from 0 to R, that is inside that sphere, it's a, it's y is equal to x graph. At center 0, electric field is 0, will move up until certain point, and then you will notice something like this until it just approaches the surface, right? Until it just approaches the surface, nothing is going to change. Electric field is being measured inside a dielectric medium having dielectric constant. You're just near about, just as you reach the surface. Let me write down a few things. This is A is equal to R, okay, and you have something like this. Okay. Oh yes, so the graph would be moving from here to here, a straight line. This is y is equal to x graph, y is equal to mx graph, and then suddenly you would see a jump. Jump is going to be somewhere over here, depending upon the dielectric constant. Z times the jump would be there from this value, and you'd observe graph should look actually something. Alright, this is y is equal to 1 by x square graph. It looks little off the way. For this again. Y is equal to something divided by, or y is proportional to, I would rather keep it as proportional to, safer side, is equal to thing divided by 1 by x, x square graph. Okay, this indicates this part, and this A is y is equal to mx. I hope this is clear. I'll come back to the point again. So what did we do is we analyzed, we founded electric field, two equations. We did all the Gauss Law thing, and we said inside the surface we are present in a medium, it has a dielectric constant, hence charge polarization will be there. Irrespective of whatever fields flow, there will be some opposition field. If at all a charge is present, or whatever it is present, or it's a dielectric medium, hence you can assume it to be like present with some E by Z field. In this case, if I say the dielectric medium as dielectric constant Z or relative permittivity Z, then there would be and divided by Z, a little weaker fields in a medium. So now what happened was we derived this equation earlier, which came out to be E is equal to rho divided by 3Z epsilon naught into A. Okay, we just derived that equation in the earlier problem, so don't worry about it. So we found out this entire thing is constant. Okay, this is constant, and this guy is A, which is nothing but the distance R or X in your cases sometimes. Okay, we just took it as A, and we saw that okay, this is a constant, this is varying with A, and since we are inside the dielectric medium, we write it by Z. When we moved out of the dielectric medium, the point at which we are measuring the electric field now is no more a dielectric medium. What happened? We didn't have that Z, we did entire calculation, we found out a constant, but this time we found out as if this entire charge is focused at one point that is going to be at the center. And we said that, you know what, there should be a 1 by A square. 1 by R square, as you did in your Coulomb's law, and divided by the test charge. Hence you got the field. Yes, we got that thing, and we just wrote down the equation. Then do the graph. Until A is equal to R, it is inside the sphere, and the graph should be Y is equal to mx graph. And once we moved out of that surface, there was a small jump or a large jump depending upon the electrical permittivity of that medium, and then it would be just a point charge graph. This is nothing but Y is equal to 1 by X square. Okay. It would rather be a smooth curve. So the graph would not be previous as the same one due to two reasons. One is this thing, due to this reason that there is a charge present inside the inside that plastic sphere. Or if at all, it is said that somehow you manage to have an insulator that is of dielectric or dielectric constant or relative permittivity as much as that of air, still the graph would be joining, but still you have this extra Y is equal to mx line. Okay, did you understand this difference? I believe this must be clear, guys. Alright, very good. Alright, very good. That is it, and now we have a case where the electric field is varying within okay, now read the question, take a couple of seconds and read the question and get started with it. It's no more a uniform charge density, and now the question is, what is the electric field at a point A within the sphere, or let's say when A is less than R, or R is greater than A, what is the electric field at a point A? Alright. Get started, students. What would you do? So if you have noticed something at every single point, at this point, at this point, at this point, the charge density is varying throughout. This entire shell has a different charge density. If you move by even a delta R, the charge density is changing. So now how would you work around these kind of problems? And typically you can expect these kind of problems in your JEE Advanced. It's pretty easy again, trust me. Pretty easy. Try it for maybe like 20, 30, 2 minutes, etc. I think this was also a JEE Mains question or JEE Advanced question, and a little recent one. And how do you work around these kind of? Alright, I think I'll get started on this. Do you think electric field is going to be zero? Again, it's a plastic sphere. Of course, electric field is not going to be zero. Option A is not at all correct. This guy is lying. So now let me just do an option analysis and try to come up with the answer, if at all we have the answer in the option. And the next thing says that it's proportional to r square. This looks like a constant. This is not true. This is also false. Yes, also. Now among this we have two options left. One it says a cube and the other it says a square. And in this you have r on the denominator magically somehow, and you have 3, you have 4. If you notice the earlier question we had 3, probably B is the answer. But let's do the problem, guys. This is not the way to solve the problem. Of course, at a distance A, we'll be drawing a Gaussian surface, and we'll be saying that now the complication is, yeah, it's B. Good, Prabhat. Now we'll say, you know what? We are going to draw a shell. This shell looks horrible. Let me redraw this. Okay. So what we are going to do is we have to calculate, we have to integrate things, if you have got it. Yeah, good, Prabha. Sometimes, yes, students, you want to go by method of elimination. Especially in JEE Mains, you want to make use of method of elimination so that you can maximize your score. So I'm going to say at a distance r, or like a distance r, the field is varying as A into r. Okay, at a distance r, this sphere, I'm analyzing in terms of shells. This r is varying from 0 to A in this case, because I'm only supposed to find out the charge enclosed within the Gaussian surface enclosing that, with the radius A enclosing the charge. So it is 0 to A, that's what I'm supposed to know. And how much charge is enclosed in this case? It's quite simple. It's really simple, guys. What I'm saying is, if there is a shell, and if I keep adding this shell from 0 until A, is the same thing as integrating from 0 to R. But how much charge does that shell have? If I'm going to say dq charge present in that shell, okay, how much charge does the dq contain? It's nothing but 4 pi r square into dr, which is the volume. Let me come this way around. Okay, what I meant to say is, this is nothing but, if I'm trying to calculate the charge present on the shell, okay, it is nothing but rho into dV volume. What is dV volume? dV volume is 4 pi r square dr. You know this thing, shell as 4 pi r square surface area multiplied by small with dr. If I say this is the dr, this thing, thickness, it's 4 pi r square into dr is the volume. Now rho is also varying with r, hence we are doing this dq analysis. We are saying within the small distance dr, it's not varying much. This is going to be 4 pi r square into dr. Alright guys, we have just derived dq, but we have a little bit of process left, or after that process you know the answer, because you know the area of the Gaussian surface really well. That is nothing but 4 pi a square is the area of the Gaussian surface. Now we have dq, and this is just dq, but if I need to add each shell from 0 to the distance a, I would say this is nothing but dq multiplied by, integrated over 0 to a would give me total charge enclosed within the Gaussian surface. Okay, so we are basically going to integrate this term, which is not a big deal. You guys are dealing with even advanced math than this, so just integrate it quickly. So it should be dq integrated over 0 to a, and you have what do you have? You have something like 4 pi r square dr into rho into r. Okay, let me write it down this way then. Okay then, we have written this is dv into rho into r, and we are going to integrate this from 0 to a. Okay, This is also integrated from 0 to a, but rather this is not the right way to write it. But anyway, integrated from 0 to a. Okay, just for understanding there, I wrote 0 to a, but that is not the right way to represent. Alright, then this is nothing but 4 pi r cube into this was what guys, I made a small mistake. This isn't rho. Okay, we said rho r. What went wrong? This went wrong. What went wrong? It's not rho, it's a. Right, because rho is again varying. There was a constant a. A should have been mentioned as a constant. Okay, very simple problem though, don't worry about it. These are like minute mistakes that you didn't even notice in your exam, or you have integrated it and you have solved the question. Okay, it's a simple problem, trust me guys. So this is r cube, and here also we would have an a. Connect those small parts and you would have an a outside as well, because it's a constant. This into dr, of course you will also have 4 pi outside. So dr, r cube dr, integrated r cube, just integrate that r cube. What would you get? You would get r to the power 4 divided by 4, a into, or 4 pi a into r to the power 4 by 4. This is cube. There's no more d cube. This is integrated d cube. Now this varies from a distance a to 0 or 0 to a, sorry. So what would be your total charge enclosed? This is what we are talking about. This is charge enclosed. This is not the entire charge, of course. Entire charge you will multiply, you will integrate it from 0 to r. Okay, so if at a distance r from here is being asked, notice the graph is drastically going to be different, isn't it? How much is the total charge? Total charge, okay, it will act like a point charge, but still the graph would look different. Okay, in terms of your constant, etc., because it's not one charge cube. It is like, you know, a bunch of charge cube that you need to add up at the center. Let's come to this point. Simple. So 1 would be 0. So you would get something like a to the power 4 by 4. Get confused. One a is constant a, other a is varying a. Okay, we should have kept it as r. Okay. Now there we go. We have this equation. Rest is just this was also quite easy, I believe, for you. If everything has been done and understood from the beginning, pretty easy concept. Now we are going to get into saying that sigma is equal to sigma E, which is nothing but electric flux is equal to charge enclosed by A into epsilon naught, as we did earlier, or epsilon, which is written as K into epsilon. We can say epsilon is nothing but K into epsilon, which is what? Which is E into A, electric field into area. And what is the area of your Gaussian surface? 4 pi A square. This is the Gaussian surface, right? It's 4 pi A square. Quite simple. Just substitute the value of Q enclosed that you found out. From 0 to A, you integrated it anyway. You got it something like, I believe you got it as, A is also, A is actually constant in this case, but throughout your spherical shell, it is varying. When you draw the graph, it's a varying thing. Okay. So now, what will you get? You will get something like 4 pi A into 4 pi A to the power 4 divided by, you will get something like I'll look at it by 4. Yeah, okay, that is it. Into, I'm writing down this equation, this part of the equation, into 1 by A into epsilon naught, sorry, Z into epsilon naught. We took dielectric constant as not K but rather Z. Correcting few things, but you can keep it as K as well during a calculation. I just kept it as Z because your Coulomb's constant is also going to be K. I do not want you to get confused in that part. So this is going to be 4 pi a square, right? To cancel out 4 pi 4 pi, it's a very simple problem, guys. I told you in the beginning itself, it's a very simple problem. If you don't, there's nothing to mess up literally except for z epsilon part. If you understood that, it's quite a simple problem. What did you get as electric field? Electric field is how much? A divided by 4z epsilon naught into a square. I thought of actually changing the a to r after this question because both looks like a. Ultimately, as a. Right. This is quite simple. R cap. Was there any difficulty in this question? I don't believe so. Okay, this was a simple question, guys. Again, yeah, that's it. So yes, this was again a simple question, but how is the electric field varying now? To the power a square. If I'm plotting between E and R, I can say E inside the shell is varying with, like R square. Whereas outside the shell, so this is what you would see ultimately. This is something that we have derived already, but we have found it for at only point A. Okay, at the distance A and at this point, whatever it is, point A or point P, etc. So what we got something like this. If I'm just writing it absolutely in terms of R, so electric field we found out to be within that, because rest is constant, right? Rest is all constant. It's just okay, rest is also not constant, but anyway, I think rest is not constant. That's because of, but typically it will vary that way. Okay, because rho is varying, right? But still you'll see that electric field is proportional to R square. So you got an equation something like this, something like A divided by A square. Keep this A separate. A divided by 4 z epsilon naught into A square. Do a thing. Okay, this is A divided by 4 pi epsilon naught, 4z epsilon naught is constant, else we couldn't have integrated that A, keeping it constant. This is what we found out. Okay, I'll write it down in terms of R, a better understand. Okay, and what I'm saying is electric field. This is for R less than radius of sphere. For R greater than radius of sphere, it would just behave like some charges has been placed in its center. Alright, that is it. Really simple, guys. I told you since the beginning, it is the simplest thing that you can do. Some constant into 1 by, because total charge has been enclosed, and this will vary from 0 to R. You can simply in the earlier integration substitute instead of A it could be R, and then do the Gauss Law, etc. You'll still get it quickly. Here you have to, instead of A to the power 4, it will be R to the power 4, and you will get the equation. If you want to derive it, we can quickly derive it within few minutes, and that is possible. So let me do a small thing for you. I'll write down the value of constant as well inside. The constant would look something like this: A into R to the power 4 divided with, this is the total charge that will be enclosed. Okay. Of course, you have to take out that value for the area. So you would typically divide this equation by multiply this equation area, get the charge enclosed by epsilon naught. Okay. So saying, if you multiply this side of the equation with 4 pi a square or r square, 4 pi r square, you'd get the terms of area. Okay, anyway, let's get into this. We will get something like this, and you'd have 1 by r square. There will not be a straight line anymore. Your graph would be like something like this, something like this, like this. Okay. First time during the first phase, your with respect to r, your electric field will be moving faster. You think in terms of slope, or E is proportional to r square case. In the second case, electric field will be moving a little slower. Pavitra, so hi Pavitra, good evening. So how much of it have you completed? Like on which year aspirant you are? So that also matters, right? So in this case, when r is less than rs radius of the sphere, you got electric field to be proportional to r square. Okay, this is simple. You can just derive this thing. This just have substitute the value. Just have just wrote it as 1 by r square. You can also do the dimension and get the answer. So my question is, so you see two different cases, right? One where it is proportional to r square. As r is increasing, electric field is rapidly increasing with r square. The other case, you're seeing electric field is decreasing with r square, rapidly decreasing with r square. No, which year aspirant you are, Pavitra? (2021) aspirant. Good evening. Good evening. Alright, if you are 2021 aspirant and you have already solved, you are halfway through the book, continue it. I mean, which I haven't gone through PM Sharma, so I don't know how good it is. But PM Sharma, even for physics, I am not sure about it. I typically refer to DC Pandey, Resnick, etc. I think at the moment, you can either do DC Pandey, C. Verma, if you are not confident about the book. But anyway, you know, the quality of problems do matter. That is it. And it should have correct solutions. That is the most important thing as far as your book is concerned. So make sure your book has the correct kind of solutions, and it has a lot of different model problems. And if you're 2021 aspirant, you're already halfway through your book, and if you run, you know, like some topics 70%, some topics 30%, maybe you don't want to skip that book, you want to complete that book. It's a good book, and I believe BM Sharma is a good book. I think typically it comes for JEE Mains from Senge's publication, or I don't remember, one of that publication. Alright, I believe you got your answer for your query. So this is a very interesting case. A charge Q is given to a solid metal cube of side A. The electric field at a distance from the center of the cube where A is greater than B. The cube this time, and you gave charge Q and the electric field at a distance from the center, what it should be. Whether it should be 0, whether it should be rho sigma into R divided by d epsilon naught, take sigma as alright. So anyway, the answer is pretty visible to you. Take sigma is equal to Q by A square. Right. So think about it carefully. See, it's a metal, you know, like a metal conductor, and this is a cube. Now at a distance d, what is happening? At a distance d, what is happening? There is no charge enclosed. Even though this charge Q is given to you, there is no charge enclosed. Whatever kind of Gaussian surface you want to draw, you can draw. Charge enclosed is 0. Its electric field will be 0 simply. Don't get lured by the shape. Okay, really simple. Cube, still charge enclosed is 0. It's a solid metal cube. Nothing is going to change. It's the same thing. Alright, I believe with this we have completed Gauss law. all or the majority of the concepts around Gauss law, but Gauss law fails to explain few phenomena, or it is only meant for few things. Where let's say you have like a point charge like this. This is not point charge, but typically some charge distribution across let's say even an insulator, and it's given a charge Q. When you try to analyze through Gauss law, you will say all the fields exist like this, and you will calculate the field at some point. But if you notice and you say here no field may exist or something like that, if you remember all the calculations. But if you remember the things, this at a very large distance, like r is equal to near about infinite or something, like a very large distance compared to the dimensions of the cube, what would happen? It would act, this entire cube would behave like a point charge. And it would not be able to efficiently, you need to actually do for each face. You cannot just say, this is the cube, this is the facing side, this would be the flux. That way does not work. So that is one of the drawbacks or the complications involved in Gauss law. Of course, you can do it for each and every side. Hence, the issue is whenever you are applying Gauss law, except for the cases that we have discussed where you have point charges and you have drawn a Gaussian surface intentionally, that is just testing your concept around Gauss law. But while calculating electric field, let's say you're analyzing electric field, if your geometrical structure which contains charge is not comparable or is in the comparable size. It's not comparable means, this is miniature, this charge Q is miniature, or let's say it's comparable to the size of your Gaussian surface, your Gauss law is not very efficient. Okay, if this cube was infinitely big, you could have drawn Gaussian surfaces to analyze fields and different. Can be insulated, can be conducted in any of the cases. This may not be true. Okay, so Gauss law fails at some point, and it fails to explain phenomena where the distance of the point at which the electric field analyzed is comparable to the geometrical structure. In this case, this cube is almost like it has that the side of the cube is almost half of that of radius. So in those cases, Gauss law is failing to explain. Okay, that is it. It's the simplest chapter, but it's also one of the most asked chapter or the most asked topic among electrostatics. Will bring up more problems for your understanding, with a little bit of concepts left over around electrostatic fields. Then we'll get into electrostatic potential, which is also very interesting. Guys, trust me, electrostatics is very interesting given that you give good amount of time. Good amount of time is just during lectures, that's just during a practice as well. So practice it well, and it does not take much time. Electrostatics can be completed in a month and a half, given that you sincerely work around your lectures, etc., and you take down the notes, you practice problems. So it can be completed in 1.5 months, and you get 2 questions in JEE Mains generally every year. So yes, and that being said, guys, if you're on subscription platform, enroll to this Optics Basics to Advanced Optics B to A courseworks, in which this program will be covering optics in a very structured manner from basics until advanced. That's the beauty of this coursework, and it's a comprehensive course on optics in which we'll be covering both ray optics and wave optics. Guys, let me tell you, you typically get 2 questions, easy questions, and it's independent of rest of the topic. Don't be afraid of it. You enroll to the course and get started right away. We have just launched it. It's quite an easy course, guys. Trust me, optics is easy. And that being said, students, do not forget to share this video. Do not forget to like this video, because by sharing, you are doubling your power, you are tripling your power, and ultimately you want to do that. Share the knowledge. It's a free of cost initiative by Unacademy. And work hard and work smart to achieve your success, and avoid gossips. Keep smiling, guys. And that being said, students, you know what, if you're not yet on our Telegram channel, quickly get onto our Telegram channel. First of all, you need to download Telegram app from your Google Play Store and App Store. If you don't have one, download it from Google Play Store and App Store. And if you have one, and if you have downloaded it, just click on to this link. So download the Telegram app and click on to this link that is available in the description box below. And what is the necessity of getting onto a Telegram channel? You will get all the updates before time or on time, or on our Telegram channel, for all the lectures that is being conducted on JEE English, or any lectures that we conduct even on Unacademy learning app as a special class. So this is that one place you want to be present to get timely updates on all the courseworks happening on JEE English or even other platforms. So that being said, students, units, dimensions and measurements A to Z series is complete, and you may want to quickly check out the series by getting on to Unacademy Learning app. And guys, this is the easiest, less time taking. So both benefits, and the third benefit, it is always asked in your JEE Mains. It's typically asked in your JEE Mains. It's the frequently asked. You get one question, easy question, and you can cover it within a day or two. Hence, do check it out on Unacademy Learning app. It's a free of cost special class. And guys, if you're thinking about it this way, you know what, guys, like, I am not having an Unacademy Learning app. Download it from your Google Play Store and App Store. And guys, all you need to do is type in Unacademy on your Google Play Store, and then the first search result is going to be Unacademy Learning app. And once you find it, you click on to that button and then click on to the install thing. Okay. The most downloaded app with impacting 7 million lives a day. You're one among them. And guys, not only about this free of cost special classes, but you also get live notifications on the free of cost special classes, and you also get access to free quiz with model problems like what you can expect in JEE Mains and JEE Advanced, and also PYQs. So don't miss out Tuesday quizzes, and don't miss out Unacademy Learning app. This is something that you need to have on your checklist. So do install it. And that being said, students, you know what, if you are looking for a champions tool, a complete package, and the best thing that you can have for your JEE Mains and JEE Advanced preparation, it is going to be Unacademy subscription program. It's a structured program where you get access to the best educators across the nation, daily interactive classes with them, along with dedicated doubt clearing sessions. And guys, you know what, we keep conducting national level test series on this platform. So you'll undergo a structured coursework with a fixed schedule with test series and mega quizzes. So this is going to be the best thing that you can have for your JEE Mains and JEE Advanced preparation, especially when you can learn from the best educators across. And guys, let me tell you, we have legends like DC Pandey sir on this platform, and this is worth it, guys. And that being said, and many more best educators, top educators, and educators like IITians, NITians, etc. on one platform, aggregated and came together on one platform, is going to be Unacademy subscription with the state of art technology like what you can expect in your JEE Mains and JEE Advanced. So it gives you the entire feel of JEE Mains and JEE Advanced. All you need to do is click on the left hand top corner extension bar of your Unacademy Learning app, choose plus, choose IIT JEE as your goal. With that, you are ready for both JEE Mains and JEE Advanced, and then you will click on the get subscription. And students, let me tell you, once you click on this get subscription button, you get access, you get unlimited access to unlimited number of programs. And guys, yes, this subscription is also pretty economical. It's going to cost you less than 70 rupees a day. And this is typically meant for 11th class and 10th class, 9th class, etc. And students, you know what, you can apply Murli Live coupon to get the best discount on your subscription purchase. This is how you'll get the best discount, by applying Murli Live coupon. So do not forget to apply Murli Live coupon, and do not forget to enroll to Optics Basics to Advanced coursework, and do not forget to get started now, because this is the time most of the programs are being hosted. And that being said, students, if you're looking for convenient payment options, we have something amazing for you. That is going to be our in-house pay in parts option. And we at Unacademy, have released this option, our in-house option, so that it takes away the hassle of paying all the fee at once. It takes away the burden of paying all the fee at once. And guys, we also give you access to no cost EMI. And with this, you can again split your payments into multiple parts. Yes, using these two options, you can conveniently pay your, your subscription fees. Not all at once, but splitting it into multiple parts. We also have access to traditional payment modes like debit card, credit card, UPI, etc. And that being said, students, if you are a long-term dropper, or if you're a 12th class student, this might be the program for you. Yes, guys, this might be the program for you. And let me tell you something. This is also pretty reasonable. It comes at a cost of less than 2,900 at a cost of 2,888 only. And students, you can apply Murli Live coupon to get the best discount on your subscription. Apply Murli Live coupon and get the best discount. Don't miss it out and never miss out discounts. And we have 6,000 plus programs and materials for your JEE preparation. 1,000 plus live programs right now going on just for JEE Mains and JEE Advanced preparation. Enroll in the program, enroll in the correct kind of program, enroll around your weaknesses, enroll around your strengths depending upon your strategy. Also do check out the strategy session to learn more about your 2021 preparation strategy. That being said, students, take care, stay safe, bye bye. And I believe, Pavitra, your question is answered. If not,